how to draw a body plot from a transfer function. Let's say we have a transfer function that is given like this: h of s that is equal to s plus 10 times s plus 200 divided by s plus 20, and let's put a square here, and then s plus 1000. Okay, this is our transfer function. When you have a transfer function like this, the first job is you have to make it to +1 everything. In order to do that, what you have to do is you have to look at the corresponding numbers that is next to s and divide by them. For example, for the first one, this is s divided by 10 plus 1 right here, and then next one is s divided by 200 plus 1 right here, and the next one is s divided by 20 plus 1 whole square, and the next one is s divided by 1000 plus 1 whole square. Now if we are dividing, we have to multiply as well. So what we do is we look at the denominators. We have 10 and a 200, so 10 times 200, 2000. You multiply this one by 2000 here, and in the denominator, if you look at 20 and 1000, but this 20 is squared, so which means 20 square, which is 400. So 400 times 1000, 400,000. Okay, and now we can this 400,000 right here. So now we can simplify this one. Like you can look at this 30 cancels, and we get 2 over 400, which is equivalent to 1 over 200. So I can just put 1 over 200 here. Okay, 1 over 200. And that is the simplified version. Like I just made it all into +1 like this, and I look at the denominator and I multiply and put it on right here. Same here as well. 20 square, 400, 400,000, and when we simplify, we got 1 over 200, and this is our gain. Whatever we simplify and get this right here, that is our gain. Now we have to calculate the gain. To calculate the gain in decibel, we use this equation. Gain is equal to 20 log 10, and whatever the gain here. Now the gain we have is 1 over 200, so we put that one right here. 20 log 10, you can write it as 1 over 200 or 200 power minus 1. If you put 200 power minus 1, then the 200 will be here. The minus can be brought to the front and put it like this. And then if you calculate the value of this, you're going to end up getting negative 46.02 decibel. Okay, and that's our gain. So now we have the gain, and the next thing is we have to look at the point of interest. And in a transfer function, you know that whatever the values on top is zeros, and whatever the values in the bottoms are poles. So zeros get the positive value, poles get the negative value. So if you look at the points of interest, we have 10 is a 0 and a 200 0. These two are gonna take the positive value. So let's say 10 here, and then 200, let's put it here. So these two are gonna get the positive value since those two are zeros, numerator, and in the denominator all of them are poles. So here we have 20 here, so that's going to be a minus, and then minus 20, and then also we have 1000. I put minus 22 times because we have s plus 20 square, so that's why we get 22 times, and we have 1000 as well, so I put a minus 1000 right here. And then this is our breaking radians per second, that's the angular frequency. Okay, these are the frequency we had to take care of. Now I need to go to the next page in order to draw this diagram. I just need the point of interest in order to draw the graph. I copy this one and bring it to the next page so we can draw the body plot diagram. Okay, these are our point of interest. And first let's start the body plot diagram. The body plot diagram, we have one for the decibel and one for the angle. Let's look at the one that is for the decibel. Okay, this is our body plot. This is decibel right here. And this one is radians per second. And here we can put something like 10 power 0, 10 power 1, 10 power 2, 10 power 3, 10 power 4, and so on. Okay, and the initial value we have to look at is the gain. The gain we got is negative 46.02. So let's say that is somewhere here. Okay, let's say this is our negative 46.02. This is our A, which is negative 46.02 decibel. We start from right there, and then we look at where the point of interest happening. So until 10, nothing happening. So I put a straight line for it until 10, which is 10 power 1. It's right here. Until 10, nothing happening. And then at the 10, if it's a 0, we are going to get a positive 20 decibel. If it's a pole, we are going to get a negative 20 decibel. So this is a 0 right here, because you see the positive sign. So we are going to have a positive 20 decibels. So we are going to have graph that is going up until the next point of interest, which is 20. So if you look at the graph, this is 10 power 1, and this one is 10 power 2, which is 10 to 100. So the 20 must be somewhere here. So let's say this is the point 20 right here. Okay, let's say this is the point 20, and then the positive 20 decibel per decade is going to go up to this. Okay, this is positive 20 decibel per decade. And then after the 20, we have a pole. So we are going to have a negative 20 decibel per decade, but positive 20 decibel per decade and negative 20 decibel per decade cancels each other. So it means nothing, it's going to be a 0. But since we have another pole at the same location, negative 20, it's not just negative 20 decibel, it's going to be negative 40 decibel. So we're going to have an effect that's going down until the next point of interest, which is 200. So this is 100 to 1000. The 200 must be somewhere here. So until 200, this is gonna go down. So it's gonna go somewhere right here and stop there. Okay, so this is 20 decibel per decade, 20 decibel per decade, and this 200. Actually 20 radians per second, 200 radians per second, and this is minus 20 decibel per decade. Okay, and it goes up to 200, and then the next point of interest. But at 200, what happens? 200 is a positive, and this one is a negative 20. Positive 20, negative 20, that's gonna flatten thing out, and it goes up to 1000. So we are gonna have it's gonna be 0, which means flat, and it's gonna go to up to 1000. That is 10 power 3. And at 1000 we have a pole, so which means that's going to be negative 20 decibel per decade. So we're going to have, it's going to go down again, and that goes forever. Okay, after that we don't have any point of interest, so it's going to just keep on going like this. And this is minus 20 decibel per decade. Okay, this is the decibel per radians per second Bode plot diagram. The next one is we have to look at the angle. Angle is like act in a similar way. You know what, I need more space to draw the angle, so I'm gonna copy this one and bring it to next page. I make it a little bit smaller so I can control the angle as well. Okay, so let's say this is our graph for radians per second per decibel, and then the next one we are going to draw it for the angle. Similar fashion, the point of interest is going to be almost the same, but for the angle it's going to be a little bit different. Like if you see 10, then you have to look at 1 decade before. It's like dividing by 10. So if you divide by 10, the point of your point, the first point is going to be at 1 right here. So here 10 power 0 is 1. So that is where the first change is going to happen for the angle. So this is the first one, and it happens until -20, which is 1 decade. You have to look at 1 decade before, which is 2. So 1 to 2 something is going to happen. So from 1 to 2, 45 degree. So if it's 0, it's going to be 45 degree. If it's a pole, it's -45 degree. So up to, if this is 10 power 0, that's 1, then up to 2. Okay, let's point that one out here as well. This is 1, and let's say this is 2 right here. A little bit far, but it's going to be very close. Somewhere here. So it's going to be 45 degree up. Okay, and then here we have at 2, it's a pole, and it's a negative, so this is going to be -45. Positive 45 and -45 cancels each other, so it's going to flatten out. But since we have another -45 happening at the same location, it's also happening at -20, so it's gonna go down. Okay, actually it should be starting at 2. So this is going up to 2, and then starting 2 to the next point of interest. So here if it's 200, we had to look at 1 decade before, which is 20, and if I draw the 20 is right here. So up to 20, the next one is gonna go down 45 degree. Okay, so the graph is going to look like this, and at 20 it's a 0, so we are going to have, having a -45 here. If I mention the angle here, this is a positive 45 degree, and this one is a -45 degree, and at 20 we are going to have a positive 45 degree. So -45 and positive 45 cancels each other, and it's going to flatten out. So we are going to have it flat until the next point of interest, which is 1000. We had to look at 1 decade before, so we divide by 10, which is 100. So the next point of interest is going to be 100 right here. So this 100, it's going to be flat until the 100. Okay, and then after that, what happens? So here where you have to look at carefully, like the range of each one goes up to, like initially we had it at 1, so this one is like 1 to 100, 1 to 100. You have to look at 1 decade before and 1 decade after. So this one is like started at 2 to 200, and this one is, and these two are same thing, like these two are starting at 2, so 2 to 200 is the range for both of them. And this 200 is started at 20, so 1 decade before is 20, 1 decade after is 2000. And this one started at 100, 1 decade before is 100, 1 decade after is 10,000. Okay, this is the range. Now we have to look at 100. We are currently at 100 right now. At 100, the zeros, the influence of the 0 loses, which means it had a effect, like until this range we had a effect of positive 45 degree. Now it's gone. If the positive 45 degree is gone for a flat line, what's going to happen? It's going to be negative 45. So it's going to go down 45. And it goes up to the next point of interest. So here is 100 and the next influence stop at 200. So we have to look at this. Is if this is 100, then next one is 200. That is somewhere here. So until the inflow stop is going to be negative 45 degree. And at 200, what happens? We are losing so we are losing an influence of 2 poles, so which means we are losing minus 90 degrees. So it's like adding a plus 90 to it, like we are losing the effect of minus 90 degrees, so we are adding plus 90. Okay, okay, and at 100 we lost at 100 we lost an influence of 0, which made it to go to minus 45. Hundred to 200. Okay, this one is a minus 90 here, and minus 90, this minus 90 influence goes, that's going to flatten out until the next point of interest, which is 2000. Okay, at 2000 what happens? We are losing 2000 is somewhere, let's say 2000 is here. Should be somewhere closer to this. Now we flatten out until 2000. At 2000 we are losing an influence of at 2000 we are losing the influence of a 0. So it's going to be negative 45 right now. We are going to have this one going further down until the next point of interest, which is 10,000. That is 10 to the power 4. Until 10,000 is going to go 45 degree down. Okay, at 10,000 what happens? It's a pole and we are losing a pole, and we have a pole is holding a minus 45, and if you are losing a pole, mean we are adding plus 45, so which means it's gonna straighten out and goes like straight line forever. Okay, this is the angle graph, and this is the Bode polar diagram. Like if it's a decibel per radians per second, first you have to look at the point of interest, and then if it's 0 you add plus 20, if it's a pole you add minus 20, and if the pole's happening in the same location, that's going to be minus 40. So like that you derive the graph, but the actual graph will be not like straight, this is a rough graph, but the actual graph will be like curve and stuff. It's not going to be like this, it's just like a curve like this. Okay, and this one also like curved instead of like a triangle and stuff. Okay, that's our body plot diagram for the given transfer function. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.